In this video, I demonstrate the use of the hash table collection, and I strongly recommend that you take a look at the Intro to Collections video 2030 for more information about the hash table collection and all the collections that implement the iDictionary interface. To demonstrate the use of the hash table, I've created a Visual Basic Console application called HashTableVB, and I've pasted some code into it already. At the very bottom, you'll notice, if you're familiar with the rest of the videos in the series, the car class. I've left in the implementation of iComparable in the car class, although we won't need it for this video. At the very top, I just have some notes about, first of all, the hash table. And remember from our introductory video on collections that the hash table is really the powerhouse. It has the best internal implementation of the iDictionary for large groups of items within your collection. So if you have more than 10, you definitely want to use the hash table. Just to review again, the hash table basically sets up a series of buckets. And so when we get to load factor, which is one of the overloaded constructors, whenever you create a hash table, you're going to be asked to specify the ratio of elements to buckets. And by default, I believe it's 1.0. You can change this in order to optimize the use of the buckets, make the buckets smaller. But I'll warn you that even though you have this kind of control, that .NET manages this internally, and so unless you get into a situation where you need to tweak some performance out of your hash table and you're going to do some very calculated measurements, I would recommend not touching that. But at any rate, let's take a look at some of the constructors for the hash table. They all pretty much, there's 10 different versions of it, and they range from just the new to passing in the capacity. And the capacity is the maximum number of elements that you should allow. You can also add in the fill factor that we just talked about a moment ago. Also, there is this idea of the hash code provider, and as I've noted in the comments, that you can create your own custom object that implements the interface of the hashing process. So if you don't like the way that .NET implemented hashing, or more specifically, if you want to create a different type of hashing and for your own custom objects, you can implement this iHashCode provider interface and do it yourself. But I'll warn you that that's pretty advanced stuff, and we're not going to cover it probably ever in this series of videos. Then finally, there's another that you can't see because it's off to the right-hand side of the screen, an interface that you can pass in an instance of the iComparer, and basically this is gives you the ability to implement your own object that knows how to evaluate two different types of objects or sealed objects, and we'll talk about that in a future video. But for our purposes, we're just going to use the first constructor, which is just the hash table with no input parameters. What I've done in the rest of this is very simple. Just created 5 car objects and added them to our cars collection. I will add this little note underneath of it that let me add one more thing, that let's go ahead and just loop through them and show each of the keys. Of course, we've already talked about the key collection in the previous video. And what I do want you to note, though, is I've added this little section, this little comment, is that we're going to take a look at the results. So I'm going to put a breakpoint here and hit F5. Let's go ahead and take a look at our console window. Do you notice anything about the results here? Take a look. We're going to use our little outliner tool, and we're going to start here, and notice how they're organized. I keep on getting bigger and bigger with my square, and this should give us a little bit of a clue how the hash table works. We noted in the intro video how they basically, for string objects, take all the values together and maybe they're ASCII equivalents and add them together, and it gives you a number. That number gets placed in a bucket so that when you go to look for the Grand Voyager key, it knows what bucket generally to look in, because everything that when you add up Grand Voyager, all the values, it can jump all the other buckets that it knows don't add up to Grand Voyager. Now this hash seems to work for, or that theory about the hash seems to work for um, this simple case of using strings as the keys. It may not always be true, especially when you're using your own custom implementation of the hash evaluator. So let's go ahead and get back to our IDE and just stop this. And I'll paste in some more code that should look very familiar. If you went through the previous video on the list collection, or list dictionary rather, I'm sorry. So let's go ahead and save that and run it again. Take a look at the values that come up. Whoops. Here we go. In this first case, we simply loop through all the values that are inside of our hash table. Here we access a specific element of our hash table using its key and return its properties and print them out. But the hash table does have some additional functionality that we didn't see in the list dictionary. So let's take a look at that for a moment. Go ahead and paste in some more code here. The first one is the use of the contains key. We can pass in a key name and it'll tell us true or false. As you can see here, I just used the true string of the contains key method, and I could just have returned toString just as easily, but trueString allows us to return the string value of true or false. So it allows us to take a look for a specific key, geo, and does it exist. It works exactly the same as the contain statement, so we pass in geo to that. We should see the exact same values. And then I use the contains value method of the hash table and pass in an instance of one of our car objects, and we see if that one exists within our collection. Let's go ahead and save it and build it. And then I'm going to bring up this window and run it. And notice that we get the contains the geoprism, true, contains the geoprism, still does, true. Those are the two different ways of doing it exactly the same. And then finally, contains car4, true. And then finally, I have here two methods that I don't want to get into right now, but they speak to the ability to serialize your hash table in a format that's specific to your objects that are stored within the hash table, and use the getObjectData and the onToSerialization event in order to accomplish that. And that'll come up in a new video called Serializing a Hash Table in the future. So I hope this video was beneficial, that it helped you see a little bit of the differences between the list dictionary and the hash table, and why you'd want to use each one of them. Thank you.